Alright, so what is up, everybody? And welcome to Universe Sandbox. I've been wanting to play this for a long time now, and basically what this game is about is it simulates anything you want in space. So you see, like, here's the sun, and it's an accurate representation of what the sun is. And if you go over to, let's say, the Earth, let's go back down, and if you zoom in enough, there's the Earth having a great time spinning really fast. So basically in this video, we are going to be exploring as much as we can in this game, because I don't know if I've said this enough times in the past. Ooh, I love space. This guy, he loves space. Mwah. You're beautiful. I love space. So, let's see if I can entertain myself lots with this game. And I have done the tutorial for this game, so I know what I'm doing, basically. So if we want to add another planet, then we can either click this plus button, which gives us a bunch of stuff, or we can do it another way, where if we put that down, we go into tools, and then we say add. And then it gives us all these options for stuff we can use. So I'd say that the first thing we should do to the Earth is actually, we should just simulate the Earth and the moon hitting each other. Okay, here we are. So here is the collision. So, ooh. Right now, I'm in Colorado right here. I'm recording right here. I'm right here. So, the moon hasn't exactly affected where I live yet, but it probably will very soon. It'll affect everyone. Ooh, that's bright. Check up on the Earth. What's your temperature right now? 390. Oh, whoa, it's going up. It's in the Celsius, 420 Celsius. Oh, even the ocean is on fire. How's Colorado doing? Oh, Colorado's not doing so fine. Alright, let's see. What are all these little fragments? Oh, they are hot. They are very warm. So this side of the world is just kind of chilling. They don't know what's going on over here. Alright, Colorado has almost been hit. I mean, the shockwave already passed, so there goes the moon. The moon is just gone. The Earth just ate it. I like how all the city lights are still on. Like, everyone's just, like, still like, oh, what's going on? I'm sleeping. Oh. So let's speed up what's happening a little bit. Let's just get the end result of all of this. So, the Earth is cooling down right here. As you can see, it created a little dry spot. The clouds are moving. Created a whole new continent. Jeez. Okay, let's try a different simulation here. Let's just go with the solar system again. Now we're going to try and change the sun's mass. We're going to change the sun's mass. So let me try that. So the mass, first of all, we're gonna add a little bit to that. See that? The sun's getting bigger. Big sun. Now I don't want to do too much to the point where it's supernovas, because that's a bad idea. Now see that? Now the sun is a bit more visible when it's cooler, so right now it's at about 4,619 degrees Fahrenheit, which I'll put up a thing on the screen here saying that's comparable to this. Now we're gonna cool it way down. We're gonna bring it down to 1,972 degrees Fahrenheit. Now that is still very warm, but it's not enough to keep our planet warm. So let's see how Earth is handling this. So right now the sun is just barely as hot as lava. Let's slow this down a bit. Okay. Let's see how Colorado's doing through all of this. Everything is frozen. Okay, makes sense. What if we add water to it? This will make plasma levels go up. Let's change this back to Fahrenheit, cool it down a little bit. Alright, so now the sun is 820 degrees. Now that's about the temperature of your oven. So still pretty warm, but not enough to keep Earth satisfied. Let's bring this down to negative 44 degrees Fahrenheit. Now this is colder than a winter day. So this is the sun on a cold winter day. It turns completely black, it loses all its light. I don't know if fusion is even still going on inside the core. Basically what I mean by that is the sun, since its mass is so big and since there's so many elements inside, that all that gravity at the center performs nuclear fusion, where it fuses two atoms together to form a new element, and that releases a heck load of energy. And that is why the sun can last for so long and be so warm, is because nuclear fusion is very energy releasing. We're going to do the complete opposite now, and now we're going to turn the sun's temperature back up to a very, very toastiness. So let's turn this back to Kelvin, and let's make the sun a blue sun, like this. Now, blue suns in real life are, I think, the hottest a sun can get. Eventually it'll start doing that. What happened? What did I do to the sun? Whoa, what did I do? Solid water's all the way up. Did I just turn it into a planet? Wait, what's happening to everyone else? You are very frozen and deformed. And let's do a size comparison here. So, for comparison, let's grab the Earth. Oh. Venus, mind you, is the same, almost the same size as the Earth. And right now, this is the size of the Earth compared to Venus. Venus is to the Earth an asteroid right now, so I guess when I turn the temperature on the sun up, the gravity crushed Venus. So I'm sure Venus's mass is absolutely incredible right now. Wait, let's look at this. How do I look at its mass? Oh, that's a lot. So technically all of Venus is still here. It just got crushed into a ball. Okay, we'll come back to you later. Hey sun, how you doing? Where's the sun? But yeah, it looks like a gas giant now. Did I just turn the sun back into a gas giant? That's so weird. Yeah, its mass is that of Jupiter's. But it's still as big as the sun. I mean, if we get a size comparison Earth up in here, I mean... Yeah, the Earth is still really tiny compared to it. Yeah, let's zoom in on what's going on here. Yeah, look at that. So, it's still the same accurate size comparison, but now the sun isn't actually the sun anymore. We're going to try and turn Jupiter into a star, because if you don't know, Jupiter was supposed to be a star, because it's actually quite common for solar systems to have a binary star system, which means two stars are orbiting each other and there's planets orbiting that star system. So Jupiter was supposed to be our second star, and the runner-up for that was Saturn, because it's a gas giant. So I'm going to see if I can increase Jupiter's mass and see if I can turn old Jupiter into that second star that it was always destined to be. So right now it's very cold, so let's just turn this to Fahrenheit. Let's get that into the warm. Okay, Jupiter's warm. Alright, Jupiter's mass is now Milky Way. That's a size? Come on, keep going, mass. I'm gonna turn you into a star, Jupiter. I'm gonna turn you into a star. You're gonna become a star. Make you warm. You are very warm now. Now Jupiter is very hot. Look at that. It's enough to heat up Earth now. Alright, now let's go back to mass, and let's keep turning this bad boy up until it explodes into a star. Oh, this is so pretty now. But let's keep doing that. Times 10, times 10. Oh, Jupiter's a star now. Okay, I did it. Okay, so it's a very cold star right now. Its radius, we're gonna make that a bit chunkier. There we go. Now we're cooking with Jupiter. Now we're cooking with Jupiter. Can I just keep increasing its mass until something weird happens? Oh, Jupiter's a black hole. Oh, Jupiter's a black hole. Oops. Saturn, you're surviving. Oh, Saturn, I feel bad for you. I'm sorry. I'm sorry I did that to you. Oh. Oops. Jupiter, are you gonna feast upon this star right here? We're gonna make Jupiter the biggest black hole in the universe. Oh. Yes, Jupiter's huge. Jupiter's huge. Oh, I'm like changing the brightness of it. What? Did I just put more stars in the Milky Way? Oh, the Milky Way is like big now. Okay, how's Jupiter doing down here? Jupiter is still a big black hole. Good job, Jupiter. You're doing good. You're doing good. You're not as big as you know, your friend, the Milky Way yet, which we're gonna keep turning up the radius of this guy. Whee! Where did it go? Oh, okay, here's the original Milky Way. You see this? This is huge, so that's like our star right there. And then you zoom out, and this This is what I've done with it. At this point, this isn't a galaxy, this is a supercluster. Oh, look how cool that looks, though. The Milky Way colliding with Andromeda, which is actually gonna happen. Oh. Alright, let's just appreciate this for a second. I know it's just a simulation, but that's so cool looking. And the music makes it so much better! Oh, the music makes it so much better! So, let's speed this up. Is it gonna start orbiting? So the galaxy is reforming itself. Look at that. So no, Andromeda and the Milky Way have collided. And stuff is dispersing, actually. They're not... That's pretty cool. So this is Belchigese, and look, all the planets are making a 180. They're like, nope, we're going back. We're going back to the star. Let's speed this up a little bit. Here we go. Alright, let's see what happens. Boom! Whoa. Oh, oh, supernova. Oh. Huh. Why is space so pretty when it's so destructive? This is what you call a nebula. This is a supernova. So let's go back down. Now, it looks like the star actually survived. So which one's supernova? Because here's Spica, or Spisa. I don't know how you pronounce that. I've never heard of this star before, but... Oh! Yes, yes, there's multiple nebulas. Oh, let's turn off... Let's turn off trails for a second. There we go. Whoa, their textures are glitching out. Nice. And it's just gone, just like that. Oh, there goes the Milky Way. Oh, bye-bye, bye-bye, bye-bye. And I'm turning the Earth into a star right now. All I need to do is turn its mass up. Times 10, times 10. Okay, there it goes. Times 10, times 10. Times 10. There we go, it's a star, it's a star, yes, yes, it's a star. Oh, Earth is the hottest thing in the universe right now. And now it's a dead star, and there are still lights on it. Okay, so in the course of a few minutes, the Earth went from being normal, to being a gas giant, to being the hottest thing in the universe, to being a big asteroid. With people still living on it. It kinda looks cool though. I hope you guys love space as much as I do. This is really cool, what's going on right here. I really like it, and I guess I don't have anything else to say about this. It's just so cool, and I think that is the end.